Preparing for a LangChain interview? You've reached Candy Mentor, and this video is for you. We'll walk through 25 key questions you're likely to face. For each one, you'll see what the interviewer is testing, the core concepts you should cover, and a sample answer. Subscribe, like, and share, and drop a topic request in the comments. Question 1. What is LangChain, and when would you use it instead of calling an LLM API directly? The interviewer wants to assess your understanding of LangChain's purpose, abstraction layer, orchestration benefits, and whether you can distinguish framework value from simple direct model invocation. While answering, focus on LangChain as an orchestration framework, its components like prompts, chains, retrievers, tools, and agents, and when the extra abstraction is justified. LangChain is a framework for building LLM-powered applications, not a model itself. I use it when an application needs orchestration, prompt templates, retrieval, tool calls, structured outputs, memory, tracing, or multi-step workflows. If I only need one simple prompt response call, a direct API is cleaner. LangChain becomes valuable when the app grows into a repeatable pipeline, such as a RAG chatbot, an agent using APIs, or a workflow needing observability and modular components. Question 2. Explain the difference between a prompt template, a chain, and a runnable in LangChain. The interviewer is testing your understanding of LangChain's core execution model, especially how reusable prompt components connect with models, parsers, and composable runnables. Make sure to cover prompt templates as input formatting, chains as composed workflows, and runnables as the modern standardized interface supporting invoke, batch, stream, and composition. A prompt template defines how user variables are converted into the final prompt sent to the model. A chain is a workflow that connects steps, such as prompt, model, and output parser. In modern LangChain, those steps are usually runnables. Runnables share a common interface like invoke, batch, stream, and async methods. So I think of a prompt template as formatting, a chain as the business flow, and runnable as the execution contract. Question 3. What is LCEL, and why did LangChain introduce it? This question evaluates your familiarity with LangChain expression language, composability patterns, pipeline readability, and the shift away from older chain classes toward declarative runnable graphs. In your answer, talk about the pulp operator, runnable composition, parallel execution, fallback behavior, streaming support, and why LCEL improves readability and maintainability. LCEL, or LangChain Expression Language, is the declarative way to compose LangChain workflows. Instead of writing bulky custom chain classes, I can connect components with the pipe operator, prompt into model into parser. It also supports branching, parallel inputs, streaming, batching, retries, and fallbacks through the runnable interface. The benefit is that workflows become easier to inspect, test, and modify. For production LLM apps, that composability matters as much as the model choice. Question 4. How would you build a simple RAG application using LangChain? The interviewer wants to assess whether you understand retrieval augmented generation end-to-end, including document loading, chunking, embeddings, vector search, prompt construction, and answer generation. Be sure to mention loaders, text splitters, embeddings, vector stores, retrievers, prompt templates, model calls, source grounding, and how retrieved context reduces hallucination risk. I would start by loading documents, then split them into meaningful chunks using a text splitter. Next, I would create embeddings for those chunks and store them in a vector database like FAIIS, Chroma, Pinecone, or Weaviate. At query time, a retriever finds the most relevant chunks. I pass those chunks, plus the user question, into a prompt and call the LLM. Finally, I return the answer with sources, because traceability is critical in RAG. Question 5. What are embeddings, and how does LangChain use them in retrieval workflows? The interviewer is testing your understanding of semantic search, vector representation, embedding models, similarity search, and how LangChain abstracts embedding providers. While answering, focus on converting text into vectors, semantic similarity, vector databases, embedding model consistency, chunk quality, and why embeddings drive retrieval quality. Embeddings convert text into numeric vectors that capture semantic meaning. In LangChain, I use an embedding model to vectorize document chunks during indexing and vectorize the user query during retrieval. The vector store then compares similarity, usually with cosine similarity or related distance metrics. The key is consistency. The same embedding model should be used for documents and queries. Good embeddings help retrieve relevant context, but chunking strategy and metadata filtering often matter just as much. Question 6. How do you choose a text splitting strategy for a LangChain RAG system? This question evaluates your practical judgment around chunk size, overlap, document structure, retrieval precision, context windows, and downstream answer quality in RAG systems. Make sure to cover chunk size, overlap, semantic boundaries, document type, metadata preservation, retrieval evaluation, and the trade-off between context completeness and noise. I choose text splitting based on the document structure and the question patterns. For long prose, recursive character splitting with overlap is a solid baseline. For legal, financial, or technical documents, I prefer splitting by headings, sections, tables, or semantic boundaries so context stays intact. Chunk size should balance precision and completeness. Too small loses meaning, too large adds noise. I test retrieval results directly because the best splitter is the one improving grounded answers. Question 7. What is the role of an output parser in LangChain? The interviewer wants to assess your ability to control LLM responses, transform raw text into usable application data, and handle structured output requirements. In your answer, talk about parsing model responses into JSON, pydantic objects, lists, or custom formats, plus validation, error handling, and downstream application integration. An output parser converts the model's raw response into a format the application can reliably use. For example, instead of accepting free text, I might require JSON with fields like ticker, sentiment, and confidence. LangChain parsers can validate that structure and raise errors when the model responds incorrectly. This is important because production systems usually need data, not prose. Strong parsing also makes chains easier to test, monitor, and connect to downstream services. Question 8. How would you force or encourage structured JSON output from an LLM using LangChain? This question evaluates your knowledge of structured output patterns, prompt instructions, output parsers, schema validation, tool calling, and model-specific JSON support. Be sure to mention pydantic schemas, format instructions, structured output methods, function or tool calling, validation retries, and avoiding brittle regex-only parsing. I would start with a clear schema, often using pydantic, and pass format instructions into the prompt. If the model supports native structured output or tool calling, I prefer that over plain prompting because it is more reliable. Then I validate the response with an output parser. If validation fails, I can use retry or fixing parsers. I avoid relying only on regex because small model wording changes can break production workflows. Question 9. What are agents in LangChain and how are they different from chains? The interviewer is testing your understanding of deterministic workflows versus model-directed reasoning, tool selection, planning, and the risks of agentic execution. While answering, focus on chains as predefined sequences, agents as dynamic tool users, the reasoning action observation loop, and when agents are appropriate, or excessive. A chain follows a predefined path. Step 1, Step 2, Step 3. An agent is more dynamic. It uses the LLM to decide which tool to call, what input to pass, and whether another step is needed. That makes agents powerful for open-ended tasks like research, API use, or troubleshooting. But they are harder to control, test, and secure. I use a chain when the workflow is known, and an agent when decisions genuinely need to be made at runtime. Question 10. How do tools work in LangChain agents? The interviewer wants to assess your understanding of how LangChain connects LLMs to external capabilities, including APIs, functions, databases, calculators, and custom business logic. Make sure to cover tool names, descriptions, input schemas, execution functions, tool selection by the model, and the importance of safe, well-scoped tools. Tools are functions an agent can call to interact with the outside world. Each tool needs a clear name, description, input schema, and implementation. The description is important because the model uses it to decide when the tool is appropriate. For example, a finance assistant might have tools for retrieving market prices, querying filings, and calculating ratios. I keep tools narrow, validated, and permissioned because broad tools increase security and reliability risks. Question 11. What is conversational memory in LangChain, and what are its limitations? This question evaluates your knowledge of chat history management, context windows, memory abstractions, summarization, persistence, and privacy or accuracy risks in conversational applications. In your answer, talk about storing prior messages, injecting relevant history, token limits, summarization memory, external persistence, and avoiding blind trust in old context. Conversational memory lets an application use prior turns when answering the current message. In simple cases, that means passing recent chat history into the prompt. The limitation is context size. Long conversations become expensive and may exceed the model window. Summarization or retrieval-based memory can help, but summaries can lose detail. I also treat memory as application state, not truth. It should be persisted securely, filtered when needed, and never expose another user's data. Question 12. How would you debug a LangChain application that is producing poor answers? The interviewer wants to assess your troubleshooting process across prompts, retrieval, model configuration, parsing, tool behavior, tracing, and evaluation, rather than blaming the LLM generically. Be sure to mention isolating pipeline stages, inspecting prompts and retrieved context, checking model parameters, using LangSmith traces, testing examples, and measuring failure patterns. I would debug the pipeline step by step. First, inspect the final prompt going to the model. Then check retrieved documents. Are they relevant, complete, and correctly ranked? Next, review model settings like temperature, max tokens, and system instructions. If tools are involved, verify inputs and outputs. I would use LangSmith or callbacks to trace each step. The goal is to identify whether the failure is retrieval, prompt design, model behavior, or application logic. Question 13. What is LangSmith, and how does it support LangChain application development? The interviewer is testing your awareness of observability, tracing, evaluation datasets, prompt iteration, production monitoring, and debugging workflows in the LangChain ecosystem. While answering, focus on traces, runs, datasets, evaluation, prompt experiments, latency, and cost visibility, and why observability is essential for production LLM systems. LangSmith is the observability and evaluation platform commonly used with LangChain. It captures traces of prompts, model calls, retriever outputs, tool calls, latency, tokens, and errors. That makes debugging much easier than reading logs after the fact. It also supports datasets and evaluations, so I can compare prompt versions or model choices systematically. In production, LangSmith helps answer practical questions, What failed? Why did it fail? How much did it cost? And did quality improve?
Question 14. How do you handle prompt injection risks in a LangChain RAG or agent application?
This question evaluates your security awareness around untrusted documents, malicious user instructions, tool misuse, data exfiltration, and defensive design for LLM applications.
Make sure to cover separating system instructions from retrieved content,
Tool permissions, input validation, output filtering, retrieval sanitization, least privilege, and monitoring suspicious behavior. Prompt injection is a real risk because retrieved documents or users can try to override instructions. I handle it by clearly separating system instructions from untrusted context and telling the model that retrieved text is evidence, not authority. For agents, I restrict tools, validate inputs, and apply least privilege. Sensitive actions should require confirmation or deterministic checks. I also monitor traces for suspicious patterns. The key is not assuming the model will reliably ignore malicious instructions.
Question 15. What is the difference between a retriever and a vector store in LangChain? The interviewer wants to assess whether you understand LangChain's retrieval abstractions and can separate storage infrastructure from the retrieval interface used by chains. In your answer, talk about vector stores holding embedded documents, retrievers exposing a query interface, search types, filters, top K, and interchangeable backends. A vector store is the database or index that stores embedded documents and supports similarity search. A retriever is the interface LangChain uses to fetch relevant documents for a query. Many vector stores can be converted into retrievers, but retrievers can also use other methods, like keyword search, hybrid search, compression, or custom logic. I like this separation because the chain can depend on a retriever interface, while the underlying storage engine can change. Question 16. How would you improve retrieval quality in a LangChain application? This question evaluates your ability to optimize RAG performance through chunking, metadata, hybrid search, re-ranking, query rewriting, embeddings, and evaluation-driven iteration. Be sure to mention testing retrieved documents, chunk strategy, metadata filters, top K tuning, re-rankers, multi-query retrieval, hybrid search, and measuring answer faithfulness. I would start by looking at retrieval results directly, not just final answers. If relevant context is missing, I would revisit chunking, metadata, and embedding choice. Then, I might tune top K, add metadata filters, use hybrid keyword and vector search, or add a re-ranker. For vague queries, multi-query or query rewriting can help. I would evaluate using real user questions and track both retrieval relevance and answer faithfulness, because better retrieval should improve grounded responses. Question 17. Explain how streaming works in LangChain and why it matters. The interviewer is testing your understanding of user experience, token streaming, runnable stream methods, callback handling, and responsiveness in LLM applications. While answering, focus on incremental token delivery, stream or A-stream methods, UI responsiveness, long-running workflows, partial outputs, and operational considerations. Streaming means returning output incrementally as the model generates tokens, instead of waiting for the full response. In LangChain, many runnables support stream or async stream methods, and callbacks can handle token events. It matters because users perceive the application as faster, especially for long answers. Streaming also helps show progress during multi-step workflows. The trade-off is that the UI and backend must handle partial responses, cancellation, and errors gracefully. Question 18. How do callbacks work in LangChain, and what would you use them for? The interviewer wants to assess your knowledge of instrumentation hooks, run lifecycle events, logging, tracing, token usage, streaming, and custom monitoring behavior. Make sure to cover callbacks as event handlers for chain, model, retriever, and tool execution, plus logging, metrics, streaming tokens, debugging, and observability. Callbacks are hooks that run during different stages of a LangChain workflow, such as chain start, LLM start, token generation, tool execution, errors, and completion. I would use them for logging, streaming tokens to a UI, collecting latency and token metrics, or sending traces to observability tools. They are useful because LLM workflows are multi-step and opaque without instrumentation. In production, callbacks help convert model behavior into measurable operational events. Question 19. How would you manage latency and cost in a LangChain-based application? This question evaluates your practical production mindset around model selection, caching, batching, retrieval efficiency, prompt size, parallel execution, and monitoring token consumption. In your answer, talk about using smaller models where possible, caching, trimming context, optimizing retrieval, batching, streaming, parallel runnables, and measuring costs with traces. I manage cost and latency by first measuring them at each step. Then I reduce unnecessary tokens, shorter prompts, smaller retrieved context, and better chunk selection. I use cheaper or smaller models for simple tasks, and reserve stronger models for reasoning-heavy steps. Caching helps for repeated prompts or embeddings. LCEL parallel execution and batching can improve throughput. I also monitor token usage, latency, and failure rates in traces, because optimization without measurement is guesswork. Question 20. What are runnable maps and parallel execution in LangChain? The interviewer is testing your understanding of LCEL composition patterns, parallel data preparation, dictionary outputs, and efficient workflow design using runnable primitives. Be sure to mention passing one input into multiple branches, combining outputs into a dictionary, parallel independent operations, and feeding merged results into later steps. Runnable maps let me run multiple independent steps from the same input and combine their outputs into a dictionary. For example, one branch might retrieve documents, while another formats the user question or loads conversation history. Those results can then feed a prompt template. When branches are independent, LangChain can execute them in parallel, improving latency. This pattern is especially useful in RAG, where context, metadata, and user input need to be assembled cleanly. Question 21. How do you handle errors, retries, and fallbacks in LangChain? This question evaluates your reliability mindset, including transient API failures, parsing errors, rate limits, fallback models, retry policies, and graceful degradation. While answering, focus on runnable retry and fallback patterns, exception handling, parser validation failures, rate limit handling, idempotency, logging, and user-friendly failure responses. I handle failures at the component level. For transient model or network errors, I use retries with backoff. For model outages or quality issues, I can configure fallbacks to another model or simpler workflow. For structured output failures, I validate and retry with correction instructions. I also log enough context to debug without leaking sensitive data. The user experience matters too. If a tool fails, the app should explain the limitation rather than silently hallucinate. Question 22. When would you use LangGraph instead of a standard LangChain chain? The interviewer wants to assess your understanding of complex agent workflows, stateful graphs, cycles, human-in-the-loop review, and durable execution beyond linear chains. Make sure to cover LangGraph for state machines, branching, loops, multi-agent workflows, checkpoints, human approval, and cases where LCEL chains become too linear. I would use LangGraph when the workflow is stateful, branching, or cyclic, rather than a simple linear pipeline. Standard LangChain chains are great for prompt model parser flows or straightforward RAG. LangGraph is better for agents that may loop through planning, tool use, reflection, and final response.
It also supports checkpoints and human-in-the-loop patterns. For example, an analyst assistant that drafts, verifies sources, requests approval, and revises would fit a graph model well. Question 23. How would you test and evaluate a LangChain application before production? This question evaluates your quality assurance approach for LLM systems, including unit tests, regression datasets, RAG evaluation, human review, automated metrics, and production monitoring. In your answer, talk about testing components separately, building representative datasets, checking retrieval relevance, answer faithfulness, structured output validity, latency, cost, and regression tracking. I would test both components and end-to-end behavior. For components, I verify prompt formatting, parser validation, retriever outputs, and tool functions. Then, I build an evaluation dataset with realistic questions and expected traits. For RAG, I check retrieval relevance, groundedness, citation quality, and hallucinations. I also track latency, cost, and error rates. Automated evaluations are helpful, but I still include human review for high-risk use cases before production release. Question 24. How do you design a LangChain application that supports multiple LLM providers? The interviewer is testing your ability to build provider-agnostic systems, manage model interfaces, handle different capabilities, and avoid tight coupling to one vendor. Be sure to mention LangChain model abstractions, configuration-driven provider selection, capability differences, structured output support, token limits, testing, and fallback strategies. I design the application around interfaces rather than vendor-specific calls. LangChain helps because chat models share similar methods like invoke and stream. I keep provider choice in configuration, not hard-coded business logic. That said, providers differ in context length, tool calling, JSON mode, latency, and pricing, so I test each path. For critical workflows, I define fallbacks and normalize outputs. The goal is portability, without pretending every model behaves identically. Question 25. Walk me through how you would deploy a LangChain application in production. The interviewer wants to assess your end-to-end production readiness, including architecture, API serving, secrets, observability, scaling, security, evaluation, and lifecycle management. While answering, focus on serving the chain behind an API, managing secrets, monitoring traces, handling concurrency, caching, versioning prompts, securing tools, and continuous evaluation. I would package the LangChain workflow behind a service API with configuration for models, vector stores, prompts, and tools. Secrets would live in a secure manager, not in code. I would add tracing, metrics, structured logs, rate limits, and error handling from day one. For RAG, I would manage indexing as a separate pipeline. I would version prompts and evaluate changes before rollout. Production deployment is not just hosting the chain. It is operating the full LLM system safely. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.